The second technology box we have deals with how we compute values of the random variable when we have a random variable with a normal distribution. And as we look at some problems, we're going to see the difference between these two. So in StatCrunch, we would use the same calculator as we just did when we were computing probabilities. It's just we would leave a different area of that blank. So in this case, we're trying to find out what value of x makes this inequality true. So in this case, the pop-up window, again, we would enter the mean and standard deviation, but in this case, we're going to enter a probability, and we're searching for the x value that makes that inequality true. So if we go back to StatCrunch to this previous problem that we just worked, and in here we are going to take out that x value and put in a 0.1. So what we're trying to find is if we have a normal curve with a mean of 272 and a standard deviation of 9, we want to know what x value to the left of it we have an area of 0.1. Okay, so if we hit compute, okay, it tells us that that value would be 260.46. So in this case, we're given the area. So this area we gave the program and told it was 0.1, and we were asking this calculator to find the value of x on the axis. The last problem, we had the value of x on the axis, and we were asking this calculator to compute the area for us. So again, it depends on whether we want a probability, if we're given x values and we want a probability, or if we're given a probability and want an x value. But again, our main form of technology in this particular chapter, or actually in this unit overall, is going to be the TI-84. Again, it's just as fast to compute them on the calculator as it is on the computer, and the calculator is just easy to have available anywhere, and you don't need internet access to use it. So we, again, would first push second variables to open that distribution menu, but in this case now, we want the inverse normal function. So we would push 3 to pick inverse norm. And again, you would have one of the following two screens depending on whether you have the old operating system or the newer one. So again, just circle which one you have and cross out the other one. The newer system's nicer because you don't have to guess as to what it's waiting for. So on the screen on the left, if yours looks like that, you just have a blinking cursor and you're supposed to know what it's waiting for. It's waiting for an area and a mean and a standard deviation. Now, for this particular function on the calculator, that area always needs to be the area to the left of some value x. So in this case, what we have set up here to do, that's a terrible normal looking curve, but bear with me for a second. So this mean here would be 2, and we want to the left of some value, we want this area in here to be 2.25, and this value of x is what we want the calculator to find for us. So really what this inverse norm function is finding for us are percentiles. So this is 25% of the way into the distribution. So really what we're having it find is the 25th percentile. So if we go back to the calculator here, and we're going to go back into second variables to get into the distribution menu, and this time we're going to pick 3 for inverse norm, and for area here I'm going to type in 0.25, and the mean given on your textbook page there was 2, and the standard deviation was 1, and then we would highlight paste and hit enter. And again, on this screen, this is what, if you didn't have the newer operating system, what you would have had to enter. You would have hit inverse norm and it would have just been blinking. You would have hit 0.25, comma 2, comma 1. Again, the comma key is the key above your 7 key. And we push enter to have it compute. Okay, so this gives us the number 1.33 about, if we round that off, which means this 25th percentile, this value of x that we were looking for that was 25% of the way into the distribution, would be about 1.33, and then whatever units our data set had. Okay. So the note at the bottom is important, but again, we will be always using the calculator for these. So in StatCrunch, you can change that inequality to be to put that area in a left tail or a right tail. But the calculator always needs that area to be in the left tail. It is set up to compute percentiles. So if you've been given an area to the right of, let's say, 0.1, so let's say we have a normal curve, and to the right of some x value, this area is 0.1. The calculator needs the area to the left of that. Well, the total area has to be 1, so that means the area to the left here must be 0.9. This really looks like a 0.2 in here, so that's supposed to be a 0.1. Okay, so this total area here is supposed to be 1. So in using the inverse norm feature on the calculator for this one, inverse norm, that first input would need to be a 0.9. And then whatever mean and standard deviation we were given on the problem. So again, this is where context is going to become important. When they give us the number and they say, you know, we want the top 10%, if we're looking at tests on a score, the top scores are at the upper end. But if we're looking at runners' times, and our top runners are the bottom times, the faster times, the lower numbers. And so again, where that percentage gets put in our curve depends on the context of the problem. And we'll see that as we work through some examples here.